Hey everyone, today we have got a 3D scan of a door handle pocket sent in by one of our viewers. In this video, I will walk you through how to reverse engineering it using both Autodesk Inventor and FreeCAD. By the end, you will see the differences between the two CAD programs and find out whether FreeCAD can hold its own against a professional tool like Inventor. This scan was captured with the Creality Raptor Pro. The door pocket itself is made from a rubber-like material, which means it can deform quite easily. So when you flip it over to scan the other side, handle it carefully to avoid distortion. You will notice missing data along the outer shell edges that sit directly against the table. To avoid this, lift the object a little above the table before scanning. It helps capture those areas cleanly. I'm using Cloud Compare here. There is a flat surface at the bottom of the pocket, so I will select 3 points on that face to align it with the XY plane. I flipped the model 180 degrees along the x-axis so the guide pin faces downward, and then I align one side of the pocket to the y-axis. The wall line from the Raptor Pro scan come out very clean with a consistent parallel pattern. Next, I will export the file in LAS format. In Autodesk Recap, I will convert the LAS file into an RCP format so it can be attached directly into Autodesk Inventor. I will also include the download link in the description. Let's start in Autodesk Inventor. I will attach the RCP file from Recap and scale it down 1000 times. Then I will create a part on XY plane and crop the thin slice of the point cloud just above the rounded corner. I will model this as a sharp corner first and then apply fillets later. I'll trace the outer wall of the point cloud using a combination of straight lines and arcs. I'll snap a point on the lowest face of the pocket, create a sketch plane there, and then project the lines I drew earlier onto that plane. Next, I will create the top profile of the pocket. I will crop a thin slice at this location, set up a plane, and then project some of the sketches from the bottom profile so they can be reused. Since the top and bottom profiles of the pocket are different, I will use the loft command to model it accurately. I will add a 3D line here as a guide rail so the loft surface forms correctly. Next, I will fillet the sharp edges at the bottom. Next, I will model the rib edges at the top by offsetting the original profile and extruding them 3 mm. Next, I will use the thicken command to hollow out the model and remove the top face. Next, I will add some cosmetic extrusions. These lace lips have a rounded profile, which I will create using the fillet command. Now, I'm using 3D lines to define a plane, which I will use to create a strip around the body of the pocket. Since the pocket's profiles vary along its length, I will project the cutting edges from the sketch plane and offset them outward instead of redrawing each one individually. After offsetting, I will extrude the geometry and then round the corners using the fillet command. There are 2 guide pins at the bottom. I will model them simply as cylinders, which makes the design easier to 3D print. And here is the final model. I will export it as STL file and send it to the slicer. At first, I tried orienting the print this way, but it requires too much support and left the printed surface looks poor. So I rotate the model into this orientation, and now it requires much less support. The print took about 2 hours and the result looks very good to me. Let's move over to FreeCAD. The PLY Point Cloud download link is available in the description. After importing the point cloud, I will change its color and point size. Then I will create a datum plane on the XY plane and move it down to the curved transition point. And this is where I will create the bottom profile sketch similar to how it's done in Inventor. FreeCAD doesn't have a point cloud cropping function, so you will need to slice the sketch in order to view the sliced point cloud. Next, I move the datum plane to the bottom of the sketch by pressing F5. Then the sketch will follow and move along with the datum plane. I'm using the same approach to create the top sketch profile. First, I will set up a datum plane on the XY plane, then move it upward until I get a clear view of the inner wall point cloud. When creating an arc, always lock the line first before applying the tangent constraint. Next, I will apply a loft between these two sketch profiles. But there is a surface bump on one of the rounded corners. This happens because the number of lines doesn't match between the two sketch profiles, so I will adjust them to make the line counts equal. During recording, FreeCAD crashed, which also affects the screen capture software. From this point onward, there won't be live footage of the modeling process. FreeCAD failed to run the thicken command, so I create 2 additional sketch profiles and used loft cutting to hollow out the solid. This command also caused FreeCAD to crash. But at least you can use loft cut to create the wall. And the corner fillet is still functional without any issue. This cosmetic extrusion works fine, but I couldn't extract a sketch to create the stripes along the side wall. FreeCAD threw an error, so I skip modeling them. The modeling isn't 100% complete, but it's close enough at this stage. You could still create the stripes on the sidewall by drafting a new sketch manually, though that process would take too much time for me. Alright, here's the result from FreeCAD. Thanks you guys for watching. I'll see you in the next video.